a plane designed to fly faster and higher than any of its rivals. The Boeing Tu-144. This is the story of Kennedy's dream, an aircraft at the cutting edge of technology. In the summer of 1963, President John F. Kennedy announces a major new aerospace program.
I'm announcing today that the United States will commit itself to an important new program in civilian aviation.
He calls for America to build and fly a supersonic airline that will cruise at over 3,000 kilometers per hour. One of John Kennedy's heroes was John Glenn, the first American in space. But Glenn was also the first man to fly America coast to coast at supersonic speed in the year 1957. Ever since that flight, Kennedy had dreamed of building an American supersonic transport. Others had that same dream.
The British began their supersonic aircraft program in 1943, midway through the war. It was a design, obviously, at that stage, which called for an aircraft to be capable of Mach 1.5. That's 1.5 times the speed of sound, or about 1,000 miles an hour.
The British had several projects. Among these were the Miles M52 and the de Havilland DH-108 smaller. But Britain was beaten to the prize by Chuck Yeager, flying the American Bell X-1.
To tell you the truth, I was hopping mad, because I realized we could have done it and we'd missed the boat by cancellation. Not with the DH-108, but with the Miles M52. I was to be the pilot of the Miles M52, so I'd followed this carefully, and we were 80% ready for the first flight, when, without any warning, without any consultation, the aircraft was cancelled.
On October the 14th, 1947, the rocket-powered Bell X-1 became the first aircraft to fly faster than sound.
The British were really upset that the Americans had been first through the sound barrier, because British technology was ahead of the Americans. The British just fluffed it, lacked the guts to do it.
The reason the British gave for cancelling the Miles 52 was lack of knowledge surrounding what happens to an aircraft as it approaches the sound barrier.
When an aircraft approaches the speed of sound, several things happen. The most disturbing of which for the occupants of the aircraft is the aircraft begins to shake and rumble, depending on how rapidly or how slowly you approach the speed of sound. But in aerodynamic terms, a wave builds up, an area of compressibility builds up, a shock wave. And what that does is that causes increased drag and increased heating on the aircraft, such that as you approach the speed of sound, as the shock wave passes over the flying surfaces, what that does, it causes the wings to lose lift both above and below the wing. And that has a downward effect on the aircraft. So the aircraft will start to dive if you don't do anything else about it. You'll first start to notice the problem of approaching the transonic area, approaching the speed of sound from about 0.9, so 9/10 of the speed of sound at sea level. And there you'll begin to experience a buffet as the shock wave begins to build up. And as you approach the speed of sound, the closer you get to the speed of sound, the greater that buffet will be, until that moment when you pop through the other side and that shock wave is then traveling behind the aircraft. You then punch through into an area of far more stable air, an area of almost quietness, if you like.
By the mid-1950s, military aircraft were routinely flying beyond the sound barrier. But they did so only for short periods. Sustained supersonic flight was a much bigger problem than just punching a hole in the sound barrier.
Supersonic flight for passengers is actually very different from supersonic flight in the military context. If you're going to fly passengers at supersonic speed, you have to fly them for a long, long time at high speed, whereas military operations tend to be a quick dash.
Only one country decided to tackle the challenge. Defeated in the race through the sound barrier, the British now embarked on the design and development of a supersonic airliner. It was to signal the start of a race that would transform the world of aviation. On March the 10th, 1956, the British re-entered the supersonic stakes with a vengeance when the experimental Fairy Delta II captured the world absolute speed record at 1,820 kilometers per hour. The Fairy Delta II introduced a series of revolutionary features. A long, narrow delta, perfect for cruising beyond the sound barrier, and a drooping nose to allow the pilot a better view on takeoff and landing. Inspired by the success of the Fairy Delta, the British established a committee to coordinate the development of a supersonic airliner.
The most interesting aspect of the Fairy Delta II that we see on today's Concorde was the drooping nose. Now, what that is it is simply, as you see in Concorde, a nose that kinks. One of the problems with the delta-winged aircraft, and an aircraft that is designed for going supersonic speeds, is that in order to fly very fast, obviously you need something that is as aerodynamic as possible. The problem is they are very, very difficult to fly at low speeds. So when they come into land, they have a very high angle of attack, and very, very difficult then for the pilots to see what they're doing. So they then put this kink in the nose, if you like, to have this cantilevered nose, such that in takeoff and landing, to give the pilots better visibility, they put this design feature in, which we see today.
In March 1959, the preliminary design work had progressed to a point where the Supersonic Transport Committee was able to report its broad recommendations.
There were two main recommendations. The first was for a small, fairly simple aircraft to carry around 100 passengers and do about Mach 1.2. The second design was for a 150-seater that should have been capable of Mach 1.8, which was considerably bigger and considerably faster.
By 1959, the British thinking had crystallized into two projects. A medium-range supersonic airliner, which had a rather crazy M-shaped wing, very difficult to build. And the other project was the classic, what's now the classic long, thin delta for a supersonic airliner that could fly across the Atlantic.
Now would emerge a decision that would shape the whole future of the race to build a supersonic airliner.
The design study contract in 1960, the British made it a condition to BAC, who got the contract, that they should seek international collaboration for the building of the supersonic transporter.
The first country BAC approached was the United States, but in 1960 there was little interest shown in the USA for collaboration. So the British turned to France as a potential ally.
Eventually decided to cooperate because the supersonic airliner project was just too big for either of them to do on their own. It was helped by the fact that the two different design teams in France and in England had more or less come to the same conclusion about what the aircraft should look like.
The aircraft was to be a delta-winged design. It was to be called Concorde, a word common to both languages, which means agreement or harmony. But to become credible, Concorde needed customers in the airlines. In June 1963, Concorde received the major airline order that meant it would fly. And the order came not from Europe, but from America's own leading airline, Pan Am.
Such a good customer that they could go in and play one aircraft factory leader against another. And Chip didn't mind going in threatening and saying, look, if you don't do this, I'm going to get somebody else to do it. And if I have to go to Europe, I'm going to Europe. Tripp was an overpowering figure in the industry at that time.
Pan American Airways began operations on October the 28th, 1927, with the first scheduled international flight by a United States airline. A Fokker trimotor airplane loaded with mail flew from Key West, Florida, and landed 1 hour and 10 minutes later in Havana, Cuba, a distance of 135 kilometers. Pan Am's 28-year-old founder was the legendary Wham Terry Tripp. It was Tripp's original bright idea that planes carrying mail can just as easily transport people. Putting seats in the back of each plane, he charged $100 to fly to Havana. Tripp was determined that Pan Am would always be the #1 U.S. airline.
In the post-war world, in the 1960s, Pan American Airlines was one of the big names. Most American airlines tended to fly inside America, but Pan Am had built his reputation on flying all around the world. And they did that by always buying the latest and best aircraft.
On October the 26th, 1958, Pan Am became the first U.S. airline to operate a jet passenger plane, a Boeing 707 christened Clipper America. It flew from New York to Paris, halving the normal flight time. One Tripp was also determined Pan Am would be the first airline to go supersonic.
If you joined Pan Am as a pilot in the late 1950s or 1960s, the first thing they told you was, you hang in there, guys, because you are going to fly supersonic. Pan Am saw that being the first to be with the supersonic airliner as the thing that would brand the company as the place to go.
But the Pan Am decision was to trigger an American response. Within days of the announcement, on June the 5th, 1963, President John F. Kennedy proclaimed his government's intention to support the American aircraft industry in developing and building a supersonic transport that American airlines like Pan Am could fly.
When Kennedy heard that Pan American were going to buy the European Concorde, he was apoplectic. He was furious. And he phones up head of Pan Am, one Tripp, and just gives him a bawling out. And Tripp says, well, the alternative is you give me an American supersonic airliner. So from that moment on, Kennedy decides he is going to get a hold of the American aircraft companies and he's going to make them build a supersonic airliner faster and higher in performance than the European rival.
And so the race began.
The immediate result of Kennedy's intervention in the race to build a supersonic transporter was the appropriation of $100 million worth of funding from Congress, which in 1963 was a serious amount of money.
Concorde now had an American rival. The question then became, who was going to build it? One obvious candidate was Douglas, the major builder of civil airliners, from the fabled DC-3 to the jet DC-8. But Douglas was too strapped for cash to compete. Other candidates were North American, who were already working on a big supersonic bomber, the B-70 Valkyrie, and Lockheed, which had major experience of supersonic craft, such as the secret SR-71 Blackbird. There was also Boeing, the manufacturer of the mighty B-52 bomber, and the well-established 707 airliner series.
Of all the American aircraft companies, paradoxically, Boeing was the one that had the most trouble in getting into the supersonic airline business. Boeing hadn't actually delivered a supersonic aircraft to anybody.
Its founder was William Boeing, the son of a wealthy lumberman. In 1903, Boeing dropped out of Yale University and headed for Washington State to make his fortune in the timber industry. In 1910, William Boeing went to Los Angeles for the first American Air Meet. He tried to get a ride in one of the airplanes, but not one of the dozen pilots participating in the event would oblige. Boeing came back to Seattle, determined to build and fly his own planes.
Bill Boeing was, some people think he was an inventor, but Bill Boeing was an innovator of the highest order. I think he has very few patents, perhaps if any, but he would look at a product and he could see where he could make it better.
On July the 15th, 1916, Boeing incorporated his airplane manufacturing business in Seattle, in an old boatyard. He hired boat builders whose skills in carpentry were ideal for the new aviation industry. The early Boeing company prospered, building seaplanes for the US Navy, then pursuit planes for the Army. But it was World War II that brought Boeing to the peak of success.
The war was starting in Europe, and Wright Field put out an order for bids at this time, most of the airplanes were two-engine. We were still two-engine. Douglas was doing a two-engine bomber, and another company was doing a two-engine bomber. And Boeing went in to Wright Field and said, would this procurement cover a four-engine bomber? And everybody just went berserk because nobody ever conceived of a four-engine bomber.
This was the XB-15, a four-engine aircraft with a wingspan of 45 meters.
It was so big, you could tunnel out through the wing, and you could come into the nacelle, and you could make repairs in flight.
A smaller version of this giant would become famous, the B-17 Flying Fortress, that would fill the skies during World War II.
I think they ordered 13 or 14 what they call test airplanes, and that led to the Flying Fortress. I don't remember exactly how many were built, but it was around 13,000. And that airplane then went through the A series, B series, C series, all the way to H, as I recall. I'd say the story of the B-17 was it was such a versatile airplane, was able to keep carrying more bombs, more turrets.
As American men went to war, women built airplanes. Thousands of women took up the slack in the workforce and helped boost production at Boeing from 60 planes per month in 1942 to an astounding 362 planes per month by March 1944. The B-17 was followed in 1942 by the B-29 Super Fortress. In Wichita, farm hands, housewives, and shopkeepers built B-29s on 10-hour shifts, day and night, during what later became known as the Battle of Kansas.
World War II transformed the fortunes of the Boeing company. Before that, it was a serious manufacturer, but planes were built in small numbers. World War II meant Boeing was producing vast numbers of giant bombers on huge assembly lines.
After World War II came the B-47, America's first jet bomber. And on April 15, 1952, Boeing test pilot Tex Johnston made the first flight with the B-52, which was to dominate the skies for the next 50 years. Then, Boeing took a gamble.
In the 1950s, Boeing was doing quite well in military contracts for the B-47 and the B-52 bombers. But no aircraft company, can afford not to look ahead because it takes a long while to develop aircraft. And so they took a bold decision. They decided, well, let's take some of the profits from the bombers, some of that technology, and see if we could mix that into an aircraft that passengers would want to use, that the airlines would want to buy.
We had all the knowledge of the B-47, the B-52, so it wasn't too big a job in the wind tunnel to develop a low-wing airplane that could be used as a tanker. And we knew they needed a tanker, so there had to be a tanker. And we hoped it could be a passenger airplane, although we weren't really sure that that was the case. So that's why the Dash 80 was born.
The Dash 80 took to the air under the control of Tex Johnston, who had flown the B-52. Johnston was determined to show Boeing had built a great plane. So he barrel-rolled the Dash 80 over the Seafair hydroplane course on Lake Washington on August 2, 1955, a maneuver that only nimble fighter aircraft usually do. Boeing's president, William Allen, was there to witness it.
And Allen turned completely white, looked over at his technical advisor, Wellwood Beale, and he said, "Did we authorize that?" And then just before he could turn around, here he came back again and did it once more.
Boeing's gamble paid off. The Dash 80 became the prototype for the KC-135, the first jet aerial tanker, and that turned into the Model 707, the first in a long line of Boeing commercial jet airliner. Boeing had done something clever with the 707. Using about 1/10 of the fuel, could carry as many transatlantic passengers a year as the $30 million Queen Mary ocean liner. Boeing had created a market and killed the passenger liner. In 1958, with the 707 entering service with Pan Am, Boeing set up a small group to concentrate on developing a supersonic passenger aircraft. In 1960, the company was spending over $1 million annually on the project. The design was designated the Boeing Model 733.
Boeing actually started work on supersonic passenger airliners very early on, right at the beginning of the 1950s. But in a kind of research way, is this possible? Where are the engines going? Where is the metallurgy going? But what you begin to see is by the end of the 1950s, they're starting to get quite serious about it. They're beginning to think this can be done.
With Kennedy's call for America to actually build the SST, the Model 733 could become reality at last. Throughout late 1963, the three contenders for the prize of building the American SST, Boeing, Lockheed, and North American, worked in secret on their designs. Could the late American competitor still capture the market? In late 1963, metal for the first Concorde was already being cut. Would America catch up? There was a recent precedent. The British Comet had been the first jet airliner in service in the 1950s. But a series of fatal crashes revealed serious design flaws that had resulted from the Comet being rushed into airline operation to beat the Americans. As a result, the Boeing 707 came from nowhere to dominate the skies of the 1950s and 1960s.
The Americans came late to the supersonic race. They wanted to leapfrog the Europeans, and so they decided to go faster. The Europeans were going for Mach 2.2, which meant they could build Concorde out of existing materials using existing technology. The Americans decided to go way up to Mach 3 through the so-called heat barrier, which meant that because of the stresses on the plane at those speeds and the heat that would build up on the fuselage, they had to use new materials. So the Americans were going for a technological breakthrough to try and get ahead of the Europeans and bury the competition.
To beat the competition, both at home and in Europe, Boeing proposed a plane that was far bigger than Concorde. It was designated the Tu-707.
Boeing realized that if they were going to beat the Anglo-French Concorde, they would have to be bigger, better, and faster. So their design was for a faster aircraft and for one that would carry 2.5 times the number of passengers as Concorde. So instead of 120, we're looking at 277 passengers on board.
To help design its new Tu-707, Boeing built an amazing life-size mock-up. The aircraft was 93 meters long, a third bigger than Concorde. There were 277 seats, 30 first class and 247 tourist. 2.5 times the number of passengers the small Concorde was designed to carry. The seating layout in the Tu-707 was revolutionary. Till then, seating in planes was 2 cramped seats on either side of a single aisle, which made planes seem very claustrophobic.
Boeing decided that in order to entice people into this new aircraft with these fancy speeds, they'd have to offer a bit of something else. And so they made the fuselage bigger so they could get more seating in. Today we are very used to three sets of seats, 2 aisles. But this was the first time when Boeing was developing the supersonic airliner that they decided to introduce that into an aircraft.
By comparison, the Concorde has a very narrow fuselage and the old-fashioned two-abreast single-aisle layout. The Tu-707 would be powered by 4 massive turbojets, each capable of generating nearly 3 tons of thrust. At takeoff, the Tu-707 would weigh over 300 tons.
Boeing 2707 had two other very interesting features. The first was a drooping nose, not unlike we see on Concorde today, to allow the pilots much better visibility in takeoff and landing, and then to be flicked up for that needle-like high-speed flight. The second design feature was also to do with the differences between low speeds for approach and landing and high speeds in supersonic, and that was the swing wing. The wing was able to pivot for those slow speed areas, making it easier and safer to fly when taking off and landing. But then when it was up above the Atlantic or Pacific or wherever it was going to go and approaching its speeds of Mach 2, you could sweep the wings back and get a very similar effect to the Delta.
The wings on the mock-up of the Boeing 2707 could be moved manually from fully aft with a 72-degree sweep to fully extended with a 30-degree sweep.
The Boeing supersonic airliner was really pushing the boundaries of aviation technology. They were going to go faster, they were going to go faster for longer, which meant new materials, new kinds of engines, new kinds of avionics. It was a risk.
One group who sought that were the Lockheed Company, who were busy with their rival SST, the Lockheed L-2000.
The Lockheed design for a supersonic airliner was simple, elegant, beautiful. No complex moving parts like a swing wing. They'd adopted the narrow delta that everyone knew was going to work. It was within the boundaries of what was possible. They were minimizing the risks, and that's why it was a serious competitor.
As the time for submitting final design entries drew closer, Boeing was still plotting to outdo the competition.
As the design process went on, it became obvious that the Boeing entry was going to be terribly complex, terribly expensive. That made the airlines who were going to have to buy and use the thing frightened. So Boeing started adding on more and more passengers in the hope that it could make a profit that would make up for the escalating costs of the aircraft in the first place.
Size does help you a little bit on efficiency, at least it has on the other airplanes, and so obviously you can go overboard and be too fast, but too big. But I think that we felt the Concorde was too small to be a successful system.
It was the last day of 1966 when the final design winner was announced. It was the revolutionary Boeing design.
I think it was a very tough competition. The reason we won the configuration was not necessarily that the airlines liked our configuration any better. My personal opinion is that I think that they felt that they would rather have Boeing build their commercial airplane than the other two manufacturers, because we were in the process of building commercial airplanes at that time and working with the airlines. And my personal opinion is that we were picked as a company, not as a design.
It was a surprise that Boeing won because they had so little experience in building working supersonic aircraft. I mean, they were famous for the B-52 bomber, which is subsonic. Everyone else, I mean, Convair, Lockheed had built large and fairly successful supersonic aircraft. So this was the new guy on the block suddenly being given the job, and everyone thought, can they do it?
Boeing predicted that if design and construction of prototypes began early in 1967, the first flight could be made in early 1970. The first aircraft could then be ready for airline service in mid-1974. They were talking nonsense. They had no idea of the problems they were about to face.
The main problem in designing the Boeing supersonic airliner can be summed up in one word: the weight. This thing just got fat. It got heavier and heavier. It wasn't going to make money. They had to then strip out weight. And in the end, the biggest weight penalty was going to be the mechanism to make the wings swing.
As we got beyond the preliminary design stage to build it, the weight got too heavy. The empty weight got too heavy. That was the main problem. The weight just got out of hand, and we couldn't meet the weight statement that we'd estimated for the configuration at the start.
The project slammed to a halt for a year as Boeing considered alternatives. In October 1968, Boeing emerged with what was virtually a complete redesign.
There was only one way to solve the weight penalty problem. That was to take the swing wing out.
Boeing's swing wing disappeared mostly because of the extra weight. That huge hinge in there was very, very heavy.
The Tu-707 was also reduced in size. Seating was reduced to 234 passengers, though that was still bigger than Concorde. And now, a new problem appeared to haunt the project and eventually kill it: the sonic boom.
We knew it existed, but frankly, I didn't think it was that bad. The sonic boom that the airplanes we were talking about was like thunder and lightning, where the thunder hits about 2 miles away. And I guess I just didn't figure it was that bad.
In order to explore the effects of the sonic boom on, for example, urban areas, the American Air Force conducted an experiment in 1964, which is something I don't think we would ever contemplate doing today. And what they wanted to do was see what effect it had on an urban area. So they they flew supersonic bombers over Oklahoma City with sonic booms or waves of shocked air passing all the time. The result was that in a very short period of time, they had around 8,000 very vocal complaints and around 5,000 complaints for claims for damages.
In 1967, immediately after Boeing had been selected to build the Tu-707, Dr. William Shurtleff, a scientist at Harvard University, organized the Citizens League against the sonic boom.
Well, actually, there were so many technical and economic hurdles that had to be addressed for an airplane like this, not the least of which was the sound. Reaching the sound barrier always created a shock wave over populated areas.
Well, that era was a miserable era for me, because here I was, an engineer trying to do things, and you had these idiots back there making it was a political situation, and he just jumped on it. This guy Shurtleff, I never met him. I don't know what his problem was. I know the British were taken by surprise on it. They were completely amazed at the problems we were getting.
Other scientists hypothesized that the exhaust from SSTs, expelled into the atmosphere at high altitude, would start a self-perpetuating chemical reaction that would ultimately deplete a radiation-absorbing layer of ozone in the stratosphere and bring on an increase in skin cancer.
I think there were other environmental concerns, perhaps not substantiated technically, about the ozone layer, about contamination of the upper atmosphere. There were all sorts of boogeymen shoved into the front of the table having to do with so-called environmental problems.
But public opinion was turning against the SST, and as resistance grew, Congress itself began to express doubts about the plane. In response, President Richard Nixon, shortly after he was elected in 1968, appointed a 12-member committee to report on the project.
Nixon was a firm believer in the SST when he came to power, like Presidents Johnson and Kennedy before him, and he felt that the SST was essential to American prestige. And in order to underline the case for the SST, he appointed a committee. To his great surprise, I think, and consternation, the committee came out against the SST and decided it was completely unviable.
Apart from the sonic boom, the Boeing SST was encountering other problems. When he set the goal for the American SST, President Kennedy had decreed that it would fly faster than its European rival at Mach 3. But at that speed, an aircraft's skin becomes red hot. You have to make it of expensive materials that will not melt or crack at those temperatures.
To reach the speed that the Tu-707 was going to go at, you had to find new materials to deal with the buildup of heat. The most effective material would be titanium. And at that time, titanium was really, really complex to machine, very expensive to get a hold of. it was going to make the whole project uncommercial.
It's tough environment, and temperatures in Maine is a real big problem. Whether you can ever design a structure to meet all this and still have enough left over to make any money with is not too clear at this point.
The British had long since decided that these problems were too difficult and expensive to bother solving. Concorde would fly at less than 2,000 kilometers per hour, where the heating problems were much reduced. Concorde could therefore be built out of standard metal alloys to keep the manufacturing costs down.
You went much faster than Mach 2. We got too hot for aluminum. I don't know. Aluminum, I can't tell you exactly, but you wouldn't want to go too much beyond 2 to get with aluminum, so you needed a better material. And titanium was quite capable. It was a good material, and we felt that it would be. So part of the program was learning how to manufacture.
As Boeing's engineers grappled with the problems, the Tu-707 program suffered delay after delay, while costs skyrocketed.
We spent several $1 million of our own company money in working titanium on the side of the outside of the contract on the SST, but maybe we were too ambitious. It might have worked at 2.5 Mach number, but I think that you go 3 and that's 400 degrees, and that's too hot.
On May the 18th, 1971, the United States Senate met to vote on a motion to end funding the SST project. President Nixon had worked hard to persuade the senators to keep on with the project, but without success. The Senate voted 58 to 37 to kill the Boeing 2707.
I think that Kennedy's decree that the SST should be bigger, better, and faster than the European rival did cause major problems for Boeing and for the whole project right throughout it, because they were always aiming for this kind of Kennedy standard of Mach 3 and all the problems that are associated with flying at Mach 3.
I think that was too hard. It just wasn't practical. I think we could go faster than the 2. I think 2.5 would have probably been okay from a temperature standpoint, but certainly any higher than that would have probably not been practical.
Europe looked like it had won the technological race. In 1973, only 18 months after the Boeing SST project was cancelled, Concorde made its first visit to the USA to attend the inauguration of the new Dallas-Fort Worth airport. During its 4-day stay in Texas, Concorde made supersonic demonstration flights over the Gulf of Mexico and proved to be the outstanding attraction in the flying displays, which formed part of the airport dedication ceremonies. But it would soon become clear that Concorde's victory was no victory at all. British Airways flew its first ever regular supersonic flight between London and Bahrain in the Persian Gulf on the 21st of January, 1976. Unfortunately, the route was mainly overland, forcing Concorde to fly at subsonic speeds on large portions of the flight. Next came the introduction of a service to Singapore. But on the 13th of December 1977, after only 3 return flights, service was suspended because of complaints from the Malaysian government about the supersonic boom over the Straits of Malacca on the west coast of Malaysia.
Ultimately, Concorde, though it made it into passenger service, it suffered the sonic boom problem that had dogged the early Boeing project. The Americans banned supersonic flight over the continental United States. Some people said that was in retaliation. Whether it was or wasn't is neither here nor there. It meant that Concorde could only fly supersonic over the Atlantic.
It couldn't meet any of the requirements that we couldn't meet. They don't meet the sonic boom, and they don't meet the takeoff noise, and I guess there are probably only half a dozen or so flying in each airline.
Concorde will never be profitable in the sense of making back the money that it cost to buy or to develop. As far as the airlines are concerned, well, Concorde makes money on an individual flight-by-flight basis because it can charge very high tickets to the kind of luxury passengers that are there.
The system exists now because it's unique and it's high cost and it's one of a kind. And if you want to make a splash, you go over on the Concorde. And okay, Betsy and I were on that one. We went over, take off from Washington about 4:30 in the we took off from Washington about 4:30 in the afternoon in a hotel room in London, 9 o'clock. It's great.
But there is one aspect of the Boeing 2707 story that has never been told. A development that was to usher in the age of airline travel for everyone. On December the 22nd, 1965, Boeing's chairman, William Allen, and one trip of Pan American Airways signed a letter of intent which committed Pan Am to purchasing 25 of a new cargo plane. Unlike the 2707 that was dominating Boeing's attention, the new plane was almost an afterthought. Boeing kept it simple. The design was just a scaled-up 707. They called it the Model 747. The world would call it the Jumbo Jet.
The 747 is an amazing story. And it started back right after the Vietnam War, where the government said, we need to move a lot of material and a lot of people around the world in a hurry.
The 747 was actually developed in tandem with the Boeing supersonic project. And the aim was to put in the 747 what you couldn't get in the supersonic aircraft, which was freight. It was just meant to be a big cargo plane in the first place.
The Boeing company in 1965 decided to scale up the 707, I think as a freighter originally, but it soon realized you could pack so many people into these aircraft and fly them at high subsonic speeds that it was very, very commercially viable, made great sense.
When the dream of supersonic passenger flight died, there was only one plane to step into the breach, the 747. The first 747 entered service with Pan Am in 1970 and started a true revolution in flight. Suddenly, the cost of long-distance air travel was within the budget of the ordinary family. The age of mass air transport was born.
I think the 747 will still be flying in 20 years. It's one of the major developments of this century in aerospace.
Curiously, there's one hangover from the old supersonic project that ended up in the 747, and that was seating arrangement. When they transformed the 747, the jumbo jet, into a passenger plane, because it was wide-bodied, they could put in a couple of rows, you'd get a lot more seats. And that was the original dream that the supersonic transport had been born with.
But Boeing's interest in supersonic passenger flight did not end with the 2707. In Russia, NASA found a mothballed example of the Soviet SST, the Tu-144, nicknamed the Concorde.
The Russian SST actually flew just a few months before Concorde. And when people saw it, they said, gosh, that looks like Concorde. And that's because, of course, the Russians had stolen, line for line, page for page, the plans of the Concorde and built it themselves.
But the Concorde never entered international service. Soviet technical know-how was not up to the challenge of building a supersonic airliner, not even with the help of stolen plans. The plane proved difficult to fly and fundamentally unsafe. Its last outing was as a flying laboratory to try and solve the environmental problems that had plagued the old 2707. Engineers from NASA and Boeing envisioned a new supersonic jet that could fly 300 passengers at more than 2,400 kilometers per hour and cross the Pacific from Los Angeles to Tokyo in a mere 4.5 hours. But that was precisely the specification the old Tu-707 cancelled nearly 20 years earlier.
The main thing that's happened is you've gone to high bypass ratio engines, and the engine cycles changed, and the noise problem isn't as bad as it used to be with a pure jet.
20 years had brought more knowledge about building and flying complex supersonic machines. But the same old problems still stood in the way. A big supersonic craft designed to fly beyond the heat barrier would be incredibly costly to build, fly, and maintain. And there would still be pollution and noise.
There is no technology anywhere that I'm aware of that says that you can bypass, overpass, whatever, the supersonic barrier. It's there. The boom just has to be there. There's so much energy involved when you go through that barrier.
The dream of supersonic transport was an engineer's dream. It was a politician's dream. It was Kennedy's dream. The passengers wanted something different. They wanted cheap tickets. They wanted reliable service. They wanted comfort. And that will always be the future of the airline business.
Now, as a matter of fact, if somebody were to ask me today, will there ever be a supersonic airplane in the U.S., built by the U.S., I would say first you got to define what you mean by supersonic. There may very well be a more advanced Mach 2 airplane, larger, more economical, and so forth than the Concorde. They may very well be. I don't know that. But we are still today not ready in materials to go to Mach 3. We just don't have the wherewithal to do it.
But the dream lives on. Even today, Boeing are still working on designs to push the frontiers of speed for passenger aircraft. The Lockheed SR-71 Blackbird flies at Mach 3. It is made of titanium, and metallurgy and materials technology are advancing all the time. Will the 21st century see the dream come true? This is the challenge and the true legacy of the Boeing 2707.
How indifferent we've become. We've forgotten what it is to be astonished. Another new plane, one more, so what? But there is something unusual about it. It's long and has a sharp snout, and its head is lowered. There hadn't been any like this before. And it has a delta wing folded back to the tail. The wing's leading edge is razor sharp. A powerful core engine unit is mounted below. And there's another singularity. It has no stabilizer. This is the new Tupolev supersonic airliner. Take off. Script, Anatoly Agranovsky. Direction, Vermisheva. Director of Photography, Khabshin. A Central Documentary Film Studios production. Andrei Tupolev, now in his 80s, possesses talent and insight to such a degree as to become a living legend. This film is about the Tu-144, his latest model in a long life wholly dedicated to aircraft engineering. When it was conceived several years ago, there were few, even among the top rankers, who believed in its practical realization. They would often get together like this and calculate, design, ponder, and discuss indefinitely.
Еще процент на 40 уменьшить относительно толщину крыла.
А что мы можем ждать от этого утончения по качеству самолета? Чего 2,50?
Качество для максимального качества. На сколько процентов? Сколько процентов? Это порядка 3%.
They had worked together for years and understood one another at a glance. It's said locally that anyone who can out-argue the general designer can count on a bonus or a promotion. Couldn't the flutter effect appear in your control system? And the body strengthening engineers will see how much metal they must add. I'll do the drawings counting on the body strengthening engineers making their corrections. Get started, and we'll find some time later for a report back. That will help us arrive at the overall final form. We discussed that question 2 days ago. It's clear now. You finished turning over the finals to Ilyushin so he can speed up his part of the job.
Окончательные материалы для того, чтобы он мог быстро исправить свою работу.
The model was tested at supersonic speed. And here the character of the streamlining was studied. The Tu-144 required 10 times more investigation in the Great Wind Tunnel than any previous aircraft. This is father and son. Andrei Tupolev has trained hundreds of aircraft designers. He founded a school of aircraft engineering. His son Alexei, chief designer of the Tu-144, has followed in his footsteps. A tailless design was chosen. What would it look like in reality? The Tu-144 would have been inconceivable without metallurgists, chemists, instrument makers, and electronic experts taking an active part in its development. New alloys and new kinds of rolled metal were needed. The electronic equipment accounts for half the plane's cost. Some 10,000 parts are made of plastics. So the building of this plane was a common achievement of Soviet science and technology. This is a fighter plane. It flies at the design speed for the Tu-144, 2,500 kilometers an hour, more than twice the speed of sound. So it's nothing new. Our foremost Army pilots have mastered it. What is new, though, is that Tupolev has put this incredible speed at the disposal of ordinary mortals. However, not only the speed, altitude, and distance barriers have been surmounted, but the reliability barrier too. The landing gear was being tested. What was there about it that instilled confidence? Should the hydraulic system suddenly fail, another backup system would take over, and then if necessary a second backup system, and even a third. So one failure is nothing to worry about, and even two failures will not cause a crash. The crew had been pre-selected and had rehearsed the flight over and over again on the ground. Airborne, they wouldn't have the time to recall, waver, or grope. They'd have to make split-second decisions, and that meant they had to know the plane like themselves. Each of them had a college education and lengthy, thorough training for the maiden flight. Commander Yelyan, give us a readiness report, please. First, we'll make the landing gear retraction and release test. I wanted to hear what you have to say about takeoff. We considered Alexei's remarks about reducing the ground run. The shorter the takeoff, the quicker we'll be airborne. Well, to you who are about to fly, fingers crossed. The maiden flight took place on December the 31st, 1968. Everything had long been in readiness. They'd been waiting for clear skies, but the weather continued foul, and nerves were wearing thin from the strain. Finally, however, the very last day of the year dawned clear. The mercury fell, and visibility rose. Andrei Tupolev had watched 120 maiden flights, and here he was again, waiting. Meet Flight Commander Edward Yelyan, Engineer Yuri Zalivestov, Leading Test Engineer Vladimir Benderov, and Second Pilot Mikhail Kozlov. Yes, it was a fine day indeed. It was good to be alive on a day like that, as a well-known test pilot put it. This is Dolphin 1 ready to take off. Permission granted. Got you. Some compare it to a bird, for a bird never takes wing with its head drawn back. The plane took off and gained altitude. There was nothing left for us to do but watch and wait. Nothing depended any longer even upon the general designer. Mr. Tupolev, how did you begin?
Я вступил в высшее техническое училище.
I matriculated at Moscow's higher technical school because I had a bent for engineering. Our lecturer on aviation was Nikolai Zhukovsky.
Мы строили первый планер.
We built the first glider, and I made my first flight.
И вот во время работы Николай Егорович
When Zhukovsky decided to set up an aerodynamic laboratory at the school, he said that Tupolev had clever hands, so he would be in charge of the equipment.
он говорит, у товарища Туполева руки хорошо работают. Вот мы только его и назначим заведующим оборудованием лаборатории по авиации. А нужно сказать, что никакого...
Actually, there wasn't any laboratory at all, simply a big hall the school allotted us, and that's how it all began.
Когда же пришла революция, то мы, около Николая Егоровича Жуковского, был уже тесный кружок людей, которые, приходя к нему,
When Soviet power came, Nikolai Zhukovsky had gathered a close circle of people dedicated to aviation.
авиацией на всю жизнь. И мы хотели всей группой вместе
We all wanted to help our Soviet country.
нашей уже советской России.
Tupolev has advanced through nearly every stage of aviation. He even recalls planes of plywood. He built the first all-metal aircraft. This is one of them, the ANT-3. ANT are his initials. And another, the Maxim Gorky, at that time the world's biggest. And this is the ANT-6 at the North Pole. The famous ANT-25's non-stop flights won world acclaim. It took Chkalov 63 hours to fly non-stop from Moscow to the United States. This is a Tupolev heavy bomber taking part in a landing operation. The war over, the Dean of Soviet aircraft designers again produced projects which could be classed among the boldest. The Tu-144, flagship of the Soviet Civil Air Fleet. Tupolev ushered in the jet airliner era, and now he's hurtling us beyond the sound barrier. The flight continued. Now the plane raised its head. For supersonic flight, it needed a long, pointed nose. So far, so good. Everything was proceeding normally. I've stopped climbing. Everything on board is tip-top. The craft handles with astonishing ease. Now I'm banking for the first time. The ground is visible. We've finished the maneuver. Now we're going to fly over. Have a look at us from down below. How does she look? Not bad, huh? Leo Tolstoy once wrote a story told to him by an aeronaut. The first minute I was terrified. My blood turned to ice. But then all of a sudden I felt such a joyous uplift that I forgot all about being afraid. And we'll forget to be afraid too. In 3 hours and 20 minutes, we'll fly from Moscow to Khabarovsk. In 2 hours, from Delhi to Moscow. Outstripping time will become habitual. We'll take off from Moscow at noon and land in Montreal at 9 in the morning of the same day. We enter the plane, walk down the nylon carpeted aisle, and settle in a soft armchair. Smiling air hostesses will come forward to greet us, and in all probability, no one will remember anything about those who built this airliner for us. There are 300,000 meters of wiring alone. Of course we won't remember. It's enough for us that there is no noise, no vibration, no pressure drops. That at a 20-kilometer altitude, there are no thunderstorms or clouds, and that fares remain the same. Meanwhile, the flight continued. The airliner embodies all that is best in world science today. There is a computer center on board. If the flyers overlook something, the clever machine will remind them. Besides a sign flashing on, they will hear a voice saying, "Switch over the radio beacon," or "Release the landing gear." I'm coming in for a landing. Now the aircraft had lowered its head, for the flyers need a good all-round view for landing. This was not simply another new aircraft heading home. It was a new history-making stage in world aviation. It was over. The flight had taken 38 minutes. In that time, the plane could have flown from Moscow to Simferopol. These people can rejoice. Our Tu-144 was the world's first aircraft of its kind to take off. This was only its maiden flight. Tests and trials will continue.
For more than 30 years, it was a plane that captured the imagination of the entire world. From Africa to South America, from Asia to Europe, from London to New York City, the aircraft simply known as Concorde galvanized the globe. Its sleek aerodynamic structure and supersonic speed brought passengers to a whole new level in transportation. In Britain and France, the plane became a symbol of national pride. During the Cold War, where every technological breakthrough seemed to come from either America or the Soviet Union, the Concorde proved that Europe still mattered. And while this supersonic transport became synonymous with patriotism, it's also remembered as a plane that turned into an economic disaster. With skyrocketing development costs and a hefty price tag for admission, when it finally debuted, only the rich and powerful were able to fly the Concorde. And in an era of heightened environmental awareness, the aircraft was denied the most lucrative routes across the Atlantic Ocean. If not for the endless sums of government money, it may have never seen the light of day. In the end, the plane was a two-edged sword. Hated by the economists, yet loved by the people, Concorde, after nearly 3 decades in service, became one of the most recognizable aircraft in the world. During a time when faster meant better, it soared over its competition, symbolizing the absolute best in European engineering and aerodynamics. On October the 14th, 1947, aviation enters a new and uncertain era when Bell's rocket-powered X-1, launched from a B-29 Superfortress, becomes the first aircraft to break the sound barrier, flying at over 800 miles per hour at Mach 1.06. This breakthrough, along with the introduction of jet technology, causes countries to pour enormous resources into finding ways to go faster and faster. During the Cold War, with both America and the Soviet Union possessing the atomic bomb, the requirement that airplanes go supersonic is a must. This leads to a revolution in aeronautical design. Straight-winged aircraft, unable to achieve faster speeds, are replaced by swept-wing planes, most noticeably during the Korean conflict, as American F-86 Sabres battle Soviet Union MiG-15s. Bombers like the B-29 and the B-36 Peacemaker evolve into the swept-wing B-47 Stratojet and the B-52 Stratofortress. With the two superpowers investing gigantic sums of money into aircraft design, the nations of Britain and France are forced to play catch-up. In England, where the Gloucester Meteor symbolised London's place at the vanguard of aviation technology, during the Cold War, a trifecta of planes known as the V-bombers are unveiled as a deterrent force against the Soviet Union. The third in this trilogy, Avro's Vulcan, a supersonic bomber equipped with 4 turbojets, incorporates a new delta-wing design, giving the aircraft increased speed over the swept wing. Across the English Channel, where aviation was born, the nation of France also experiments with supersonic aircraft. Dassault's Mirage 3, a plane incorporating the delta-wing design, flies at over Mach 2.2 in 1958. In addition, the Durandal is also tested during this time as an experimental supersonic plane. But despite their respective legacies of being at the forefront of aviation technology, after the Second World War, with both England and France's economies shattered, it appears their best days are behind them. In the realm of military aircraft, there seems to be no way to compete with the vast resources of the United States. However, there is one area where if England and France pool together their resources, a formidable challenge can be issued against America and the Soviets. This comes in the form of a proposed supersonic transport airliner.
Mr. de Gaulle was president of France at the time, and French prestige was sort of important. The French were very, very concerned, as were the British and other Europeans, about the loss of technology prowess in the aviation industry. There was a feeling in Europe at that time that the Concorde project could be a vehicle, a catalyst to jumpstart the European aviation industry after decline.
With only military planes capable of breaking the sound barrier, there's much talk about having this technology cross over into the civilian transport market. With jets replacing propeller-driven aircraft as the preferred mode of flying, conventional wisdom leads many to speculate that the next logical step for passenger travel is the ability to fly faster than the speed of sound. In America, the undisputed champion of aircraft design, it appears inevitable that they will build an SST. The Soviets, not wanting to be outdone by their rivals, are no doubt going to follow suit.
This took place during the height of the Cold War. The Cold War was taking place. You have to remember there was competition in the aerospace defense. We had announced the Apollo program at the end of 1961, which was in effect a Cold War program.
I think that the attraction of the supersonic airplane was like the attraction of much of the space age prestige, the national honor that you had to be. If you didn't demonstrate that you could do this, you weren't in the front ranks.
This leaves the powers of Europe with an important decision to make. Will they build their own SST and compete on an international scale? The answer is given on November the 28th, 1962, when representatives from the English and French governments sign a treaty creating a powerful new consortium between the British Aircraft Corporation and Sud Aviation.
Airliner of the future. This is a model of a supersonic jet which Britain and France hope will dominate transatlantic travel. Flying at twice the speed of sound, it will hop the ocean in 3 hours. Representatives of the two countries sign an agreement to share the $300 million cost and hope to have the plane operational by 1968. The delta-wing craft will carry 100 passengers and cruise at 1,400 miles an hour. Engineers say it can use present runways and fly so high there will be no sonic shock when it breaks the sound barrier. The world grows smaller.
The two companies agree to build a supersonic transport with no cancellation clause, causing numerous airlines to immediately place orders, including America's Pan Am Airways.
Pan American World announced it has ordered 6 new Concorde supersonic jet transport, which can fly to the United States in 2.5 hours. You can tell him he's given me the best argument for not having one airline represent the United States that I've ever heard. And I'm going to spend the next time I'm here really getting a screwing to Pan America, because that sticks it right to us. How can we possibly go ahead now with our program, to which we're going to spend an awful lot of money, which was very important to the United States, which affected the balance of payments in hundreds of millions of dollars, and I'm going to put all this out and then go ahead about 24 hours before we're about to make our announcement.
Across the Atlantic Ocean, this treaty causes President Kennedy to act swiftly. And in June of 1963, at the Air Force Academy's graduation, he announces the United States' own SST program.
30,000 spectators packed the stadium at the Air Force Academy in Colorado Springs for ceremonies that will graduate cadets into officer ranks. They hear President Kennedy call for a partnership of government and business to develop a supersonic passenger plane to hold the U.S. lead in commercial aviation.
They had been under some pressure to announce this project. Vice President Johnson formed a little committee to look at the SST in the spring of that year, and he recommended vigorously that we go ahead with an SST. The Anglo-French had announced the Concorde project in '62, and that also created pressure for Kennedy to do something. There was also some pressure from the aerospace industry people to respond to what was taking place both in Britain and France and also Russia, which had its own SST program.
In the Soviet Union, work begins on their supersonic Tupolev Tu-144, with each plane now in a race to the finish line. Beginning in 1965, 2 prototypes are built, known as 001 in Toulouse and 002 in Bristol. Luckily for Britain, its aerospace industry has a huge jump on the competition, having built numerous experimental aircraft proving vital in the research and development of the Concorde. The Bristol 221, incorporating a variation of the Delta design known as the OG wing, is tested in order to determine the SST's range and payload. The TSR-2 bomber, an airplane cancelled due to the budget cuts of the 1950s, provides invaluable information about the Concorde's most daunting obstacle, its power plants. Using Bristol's Olympus engines, the TSR-2's testing sheds new light on the challenges supersonic planes face in the air. In the laboratories of the British Aircraft Corporation and Sud Aviation, rigorous examinations are carried out, investigating hundreds of materials and the effect heating has on them.
Building the Concorde required new materials, and they had concerns about heating, which had never been a sustained problem. They had people that had encountered heating in certain instances in brief encounters with supersonic flight, but if you're going to cruise at supersonic flight, then you've got a totally different heat dissipation problem.
For a period of 18 months straight, round-the-clock, 24-hour trials are conducted. At its peak, over 600 subcontractors are brought into work on the Concorde, employing over 200,000 people.
Filton, Concorde 002 stands like a great bird in a massive cage at the British Aircraft Corporation's plant near Bristol. But never has there been such an expensive bird before, nor one that has been so reluctant to fly. When she's ready to fly, she'll fly. Nothing must be left to chance. Concorde is unlike any other aircraft. Everything about her is new.
In the wind tunnels, the OG wing passes with flying colours. Full-scale mock-ups are constructed in order to show all of this SST's components. The drooping nose, a distinct feature of the Concorde, is built in order to balance pilots' visibility with its incredible aerodynamic structure. And using a converted Vulcan bomber, the Olympus 593 power plant is tested in the skies. For Concorde's team of designers, its engines proved to be the most important obstacle to overcome.
The airframe was in advance of the engines and in advance of the fuels at the time. Had you had 10-year advanced engines to put in it, then you might have possibly made it a more sustainable airplane. But as it was a prestige airplane.
For the 593's jets to work properly, air needs to enter at subsonic speeds. A huge roadblock, considering the Concorde is built to fly at twice the speed of sound. Fortunately, over a period of 4 years, a complex system of inlet doors and ducts are installed in order for this SST to travel at Mach 2. By April of 1966, the final assembly of 001 and 002 begins. With each country producing different parts of the Concorde, they're shipped across the Channel in order to make sure both prototypes are ready at the same time. Massive transport aircraft are used to ship some of the biggest pieces of this giant jigsaw puzzle. For the people of Toulouse and Bristol, seeing specially designed trailers hauling different parts of the plane are not uncommon during this time. And by December of 1967, Concorde 001 makes its first appearance in Toulouse. Its mesmerizing design stuns the entire world as aviation enters a new, high-speed age.
Toulouse. The giant hangar at Sud Aviation's headquarters was the focal point of the entire world. For inside was the most exciting new thing in the world of aviation, Concorde 001. At last, the Anglo-French brainchild, born out of the technical and very sensible collaboration of two nations, could be shown to an envious world.
While Concorde is being set up for its first test flight, in Moscow, the Communists are able to beat the Europeans, debuting Tupolev 144 on New Year's Eve 1968. Being almost identical to the Anglo-French design, it's nicknamed Concordski around the world. Unfortunately for the Soviets, it's nowhere near the Concorde in terms of structure and quality, being put together so hastily.
And the Russians ran into even worse problems with their version of it because their engines were comparatively far less efficient than the Rolls-Royce and the French engines.
In America, delays and uncertainties about their SST program continue. A competition between Boeing's swing wing and Lockheed's fixed wing design causes the selection committee to debate endlessly the advantages and disadvantages between the two.
It turned out that the swing wing didn't work. So they went with a fixed wing. Then it turned out that this plane was going to be too heavy anyway, so they tried to lighten it. But it could never really, the only way it could pay for itself is it couldn't really carry that many people, but secondly, because it was so heavy, it would have to charge a premium on the ticket, and that made the economics go haywire.
When the decision is finally made in the winter of 1966 to award the contract to Boeing, the Concorde already has a 2-year jump on its transatlantic competition. For the Europeans, a far more important threat to the aircraft's survival comes in the form of a jumbo jet. Boeing's 747, a subsonic airliner capable of flying passengers across the ocean far more cheaply than the Concorde, has those in Britain and France worried.
And in a sense, the Boeing company and airline companies as well understood that this was the real vehicle for leadership in commercial aviation. The jumbo jet, the 747, efficient subsonic jets of a variety of kinds, these were the vehicles that were going to keep America, keep leadership in America in commercial aviation, not the American SST project.
This fear is amplified when the British Overseas Aircraft Corporation decides to purchase the 747. Perhaps faster does not necessarily mean better. Despite these outside threats, as well as concerns about its growing costs, Concorde 001 is cleared for its first test flight in March of 1969.
Toulouse. The great supersonic jetliner was going to fly. A year late, millions of pounds over the estimated cost, and still a very big question mark. But on this day, a lot of those question marks would be answered. For Concorde 001, this was the chance to prove she was the superbird everyone had hoped and worked for.
Its maiden voyage is flawless, encountering no technical problems. For testing purposes, its undercarriage is kept down. In France, they can breathe a sigh of relief. 1 month later, across the Channel, 002 takes off, making another perfect flight.
You had to have really the true professionals here. There's no point in the flight in which any kind of a crew error couldn't have caused a disaster. So it was a great leap forward. We didn't have the advanced electronics that we had later. And so for its day, it was really an advanced machine.
Concorde 002 is clear takeoff. And good luck, gentlemen.
For the next 2 years, a series of grueling tests are done, studying the impact that intense heat has on the nose and body of the aircraft. In the sky, Concorde proves easy to maneuver, as the two prototypes exceed both the speed of sound and Mach 2 during this time. Every detail is checked and double-checked, with nothing being left to chance. In America, with growing protests over the environmental impact of these planes, including the effects of the sonic boom, in 1971, the United States Senate votes to cut off all funding for Boeing's SST.
Good evening. The Senate has voted 51 to 46 to cut off money for building the supersonic transport, as the House had done before. Unless private financing is forthcoming, the controversial airplane appears doomed.
With this catastrophic decision, Concorde's most fierce competition is eliminated, clearing the way for it to dominate the global marketplace. In Britain, the plane becomes a symbol of pride.
It was a proud sight. This was the day when the traditional and the modern were brought together. The British Concorde, that masterpiece of technology, came to London to be seen by the Queen, her family, and the millions who looked up with excitement for a first glimpse of this great plane.
Then, in 1973, at the Paris Air Show, a Soviet Tupolev 144 crashes for the entire world to see. This disaster raises great doubts about the communist concoction's feasibility. It appears Concorde has all but won the race to build the first fully functioning SST. now, will anybody want to buy the plane? After nearly a decade in development, the Anglo-French Concorde flies to the African nation of Senegal to begin its worldwide promotional tour. The ultimate goal of this exercise is to convince the world's airlines that speed means business. And with the right dose of public relations, executives will be convinced to buy these planes. From a marketing standpoint, the tour is an outstanding success. For years, people across the globe hear stories about this new high-speed plane that takes passengers to their destination in half the time. Its unorthodox aerodynamic design brings in crowds from Rio de Janeiro to Beijing, from Tehran to Sydney, from Fairbanks, Alaska to Mexico City. And with America cancelling their SST program in 1971 and the Soviet Tu-144 in shambles, the Anglo-French Concorde is destined to dominate the marketplace. Unfortunately, with the 1970s being defined by an oil crisis and economic unrest, the enthusiasm for a supersonic transport is a far cry from the previous decade, when anything seemed possible. The question now is, can this aircraft defy the odds by flying passengers around the globe in record time while remaining economically viable? This becomes the Concorde's greatest challenge. Across the globe, Concorde is ready to galvanize the people. Wherever it flies, the crowds are huge, anxious to see the plane they've heard about for years. During the year 1972, this SST tours Iran, India, China, Japan, and Australia, with each country's airlines showing interest in the aircraft. Kings and queens, prime ministers and presidents, rich and poor, all want to take a tour inside this remarkable supersonic jet. Unfortunately, during the 1970s, with each Concorde costing a record $31 million per plane, only the very wealthy are able to board this aircraft. Ironically, its biggest supporters are the masses, who could never afford to fly supersonic. As a result, although there's a fascination with the Concorde, the big airlines are hesitant to pull out their checkbooks. The Chinese and the Iranians flirt with the idea of buying them, but are unwilling to sign on the dotted line. In the United States, where the most lucrative destinations are to be had, President Richard Nixon tours the aircraft. His country's decision to cancel their own SST is the result of a growing environmental movement, warning Americans about the ecological disasters these planes will have on their neighborhoods and communities. A big drawback is the sonic boom. When a plane exceeds the speed of sound, a large noise capable of breaking windows and glass erupts. When scientists study the effects of this boom in Oklahoma City during the year 1964, they conclude this noise will cause a public revolt.
It turns out that the sonic boom, in fact, bothered lots of people. And this was clear very early on when they started to do research on the sonic boom in Oklahoma City. And a report came out in 1964 which showed that a huge majority of the people, quote, could not live with a sonic boom, unquote.
And the people who live with it are becoming more aroused, becoming more sensitive to this form of pollution as they are to so many others. The nation's priorities are changing rapidly, and the FAA may find that the general public has a different timetable in mind for the reduction of noise pollution. David Culhane, CBS News, New York.
It's such a hot-button issue that the United States government places a ban on all SSTs traveling coast to coast. With this decision, Concorde is limited to only the east and west coasts in America as destinations. As a result of this policy, no American airline wants to touch the plane.
Once that killed the New York to LA route, the Miami to Seattle routes, the Boston to San Francisco routes, the Washington to LA routes. Once it killed those routes, it killed about a third of the market for the whole aircraft. And therefore you didn't have as much chance to recover your cost.
People in the United States reacted to the sound barrier as a means of going against the idea of an American supersonic transport, and it of course affected the issue of the Concorde flying in the United States. But I don't think it was a defining decision. And I also think it was a bit of a red herring. I think it was put up mainly because people who were smart enough to see there was no way to make any money out of the Concorde. Building it, the manufacturer was going to lose, the government was going to lose. I think it was perhaps overinflated just so that we wouldn't do it and we wouldn't have an American contender.
As environmental groups gain strength, pickets and protests against the SST's sonic boom, against its unhealthy fuel consumption, and against noise pollution in general take place. Rumours begin that any passenger who boards the plane will become violently ill. This bad publicity sours the Concorde's reputation. Thankfully, the two countries who built the aircraft come to its rescue. When British Airways and Air France order 9 planes for service, they save the entire project from economic collapse. Unfortunately, the overseas buyers needed to make this a worthwhile government investment never materialize. What began as a European project is confined only to Europe. Despite these roadblocks, Concorde continues its worldwide tour de force. To prove it can fly in the most brutal weather conditions, the aircraft stops in America's Arctic outpost, Alaska, demonstrating that this SST can excel even in the bitter cold. Next is a flight to the polar opposite, Mexico City, where thousands of people wait for hours to see Concorde's grand entrance. With orders placed, the employees of BAC and Aerospatiale begin building more SSTs, improving the quality from the original prototypes. The Bristol 593 engines gain strength, reducing the black smoke emitted. And in 1975, Concorde receives its certificate of airworthiness. When agents are first allowed to book passengers, demand skyrockets.
A beautiful airplane that performed well. I was lucky enough to fly on it on one occasion, and it was the way to travel. There's no question about it. You arrived in London in what seemed like a couple of hours, and feeling excellent.
Although 20% more expensive than subsonic travel, during the early years, with all the hype and fascination surrounding this plane, the people cannot resist the opportunity to fly supersonic. 1 year later, the first 2 Concordes carrying paying customers depart from London and Paris simultaneously. Almost a decade after its first test flight in 1969, the dreams of this SST are finally realized. Concorde is given a boost when its only competitor, the Soviet Tu-144, fails miserably. Its crude design and enormous fuel consumption fades quickly. Only a few months of novelty flights take place, clearing the way for the Anglo-French. Despite this early success, the road ahead for this powerful new plane is going to be a bumpy one. In America, the Boeing 747 jumbo jet proves to be Concorde's greatest competitor, carrying more than twice the passengers at a fraction of the cost. In the Big Apple, where the most profitable route of London to New York is crucial, because of noise pollution, a judge rules that the supersonic airliner cannot land in the city. Over in Britain and France, many speculate that because the United States could not get its SST up in the air, sour grapes causes America to punish Concorde as a result. Only after a Supreme Court ruling is the aircraft allowed to land at JFK International Airport in 1977. Almost 20 years later, it would set the world record for transatlantic flight, travelling from London to New York in less than 3 hours. By this time, however, with rapid inflation, an oil crisis and growing environmental concerns, people begin speculating that this plane's time in the sun has passed.
People would pay the additional cost to fly faster than the speed of sound. However you valued your time, 1 times the value of your time, 1.5 times the value of your time, that's what people thought. It turned out, in fact, that this was a very questionable assumption. The whole idea that there would be a market for people paying a premium to go faster than the speed of sound on commercial aviation, in fact, was a facade. It turned out to be a facade. It was not true. It was a mirage.
During dire economic times, Concorde is viewed as a plane only for the super rich.
The clientele was superb. I mean, there were really, really rich people. For what I can recall, on the one flight that I made, there was a group of about 5 or 6 kids, all in one family, who were making their 15th or 16th Concorde flight and were totally blasé about it. So it taught me that, the Concorde was for rich guys.
The novelty effect has worn off. The enthusiasm of the 1960s, when it was first built, is replaced by the cynicism of the 1970s. Each year it's in service, Concorde fails financially, unable to turn a profit. As the 1980s begin, many feel this technological marvel's days are numbered. However, it's miraculously saved when British Airways decides to buy its planes from the government outright. With this decision, a new marketing campaign is launched to bring Concorde back to life. Discovering that its rich clientele are willing to pay more to fly supersonic, prices go up exponentially, making it a vehicle exclusively for the super wealthy. As a result, it's marketed as such, and for the next 2 decades, the plane stays afloat. Then, after more than 30 years, Concorde Flight 4590 crashes, raising doubts on the safety of supersonic flight. With the terrorist attacks of September the 11th, 2001, and the decline in air travel that follows, both British Airways and Air France decide to cancel service of the Concorde. In the end, the aircraft became a mixed blessing.
I think that the Anglo-French Concorde project may have been a model that showed the Europeans that they could collaborate in aviation. And while the Concorde itself was not successful, it may have been an impetus toward forming Airbus, which has been relatively successful in building aircraft and becoming a formidable competitor to Boeing. So in some ways, although the Concorde itself was not successful, maybe it was a catalyst or vehicle to create a successful, larger enterprise called Airbus.
Without question, its ability to travel at twice the speed of sound made the plane a first-class attraction wherever it landed. Over a period of several years, Europe's finest produced a true technological marvel, epitomizing the very best in engineering and aerodynamics. For those reasons, Concorde goes down in the history books as one of the greatest aircraft ever. In Britain and France, it was more than just a plane. It came to symbolize a time when they, and not the Americans, were at the top of the mountain. Just as England had ruled the seas with their dreadnoughts, they would rule over the skies with their Concorde. But with all its state-of-the-art capabilities, it became out of reach for the average man, woman and child, who, ironically, became the Concorde's biggest supporters. With the dim realities of the 1970s, the plane's biggest obstacles were not in its jet engines, nor in its payload, but with a skeptical public, who grew cynical at the idea of government and big business teaming up to produce a plane that only the privileged and powerful could fly on.
It was a beautiful airplane, still is a beautiful airplane, and it's just a shame that perhaps it's sumptuary. Maybe you don't need to go supersonically, and obviously not enough people need to go supersonically to justify the market.
Now, with the ability to communicate in a matter of microseconds through the use of computers, the Concorde symbolizes a much different time, when the best technology available to see each other in person was the airplane. In this era, faster meant better. And in getting people to their destination, no aircraft has been able to surpass the speed of the Concorde.
Aviation, the art of aeronautics, began with the dreamers, inventors, and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth, and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.